Hello everyone! The if statement is used for conditional execution. The if statement has these forms. If the command is single line, it can be placed on the same line after the colon. Multi-line commands start on the next line with the same indentation. The first Boolean expression is always evaluated. Each other Boolean expression is evaluated only if the values of the preceding expressions are false. If a Boolean expression is evaluated and its value is true, the statements after the corresponding colon run. The succeeding expressions are not evaluated, and the statements associated with them do not run. I'll demonstrate this with an example. We'll store Boolean expression in variables just to check if they are evaluated based on their value. We see that the very first Boolean expression for if returned true, so subsequent Boolean expressions for elif were not evaluated. When programming logic with condition, it's preferable to place condition that consumes the most time and resources in the lower elif clauses. It won't be a syntax error if Boolean expressions intersect in if-elif branches or even if they match, but commands will only be executed for the first Boolean expression that evaluated to true. It's important to ensure that conditions don't intersect. If no Boolean expression has the value true, the statements after else run. Next, let's consider the possible values that a Boolean expression can take. There are two such values: true, false. According to the Python documentation, the following values are interpreted as false: false, none, numeric zero of all types, and empty strings and containers, including strings, tuples, lists, dictionaries, sets, and frozen sets. All other values are interpreted as true. Let's check this by first comparing these values to false. We should get true. And then, using the not operator, we should also get true. The operator not yields true if its argument is false, and false otherwise. We see that only simple types give true when directly compared to false, but this didn't work for an empty string and containers. We trust the documentation, but it's always necessary to verify. When comparing using the not operator, we got the expected result. In a similar manner, let's check what Python interprets as true. We'll directly compare it to true and also without comparison. We see that only 1 when directly compared to true gives true, but without the comparison operator, any non-empty and non-zero values return true. Objects can also be checked for truthiness. By default, any object instance is evaluated as true. However, by overloading the magic method bool, we can implement our own logic. In this example, we simply return false from the method, and the truth check for the object instance also return false. Control over what is considered truthy for an object instance can also be managed through the magic method len. For len equals 0, it will be false, and for len greater than 0, it will be true. If you overloaded both magic methods, bool and len, the bool method will take precedence. Next, let's consider the comparison operators that can be used. Equal to. Check if two values are equal. Note the comparison of 0 with false and 1 with true, result true. We see that Boolean values return in true not only when compared to true-false literals, but also with integer values 1 and 0. Not equal to. Check if two values are not equal. Greater than. Check if the left operand is greater than the right operand. Note that if one of the operands is a number, you can only compare it with numerical expressions or expressions of type bool. Also, let's reiterate that when comparing numerical expression with booleans, Python considers false as 0 and true as 1. If one of the operands is a string, you can only compare it with another string. Comparison occurs character by character, according to the character codes. This comparison method is not suitable for expression of type known type. Comparison of lists occurs element-wise. Comparison of tuple also occurs element-wise. This comparison method is not suitable for dictionaries. Direct comparison of object instance is also not possible, but you can overload the bool method for item and implement the necessary comparison method. Greater than or equal to. Checks if the left operand is greater than or equal to the right operand. Less than. Check if the left operand is less than the right operand. Less than or equal to. Checks if the left operand is less than or equal to the right operand. Membership checks if the left operand is a member of the right operand. Note that in this comparison, false is no longer considered as 0 and true as 1. You can only search for a string within another string. Character case matters during the search. Membership negation checks if the left operand is not matter of the right operand. Identity check if the operands refer to the same object. Comparison occurs based on the ID of objects. This comparison method is preferable to use only for object instances, since for built-in types, Python utilizes optimization and, for example, two different variables of type in can reference the same memory location. Identity negation check if the operands do not refer to the same object. Next, let's consider logical conditions, such as not, and, or. Not returns true if the following condition is false. Returns false if it's true. And returns true if both component conditions are true. Returns false is either is false. As soon as the final outcome of a Boolean expression can be determined, Python stops evaluating the expression. This is known as short-circuit evaluation, and it can be used to improve the performance. So, if the left side of an AND expression is false, the whole expression is false. Or return true if either component condition is true. Returns false if both are false. If left side of an OR expression is true, the whole expression is true. So, placing the least expensive test to the left of Boolean expressions can potentially improve performance, as the right-hand side of the expression may not need to be evaluated. The following table summarizes the operator precedence in Python from highest precedence to lowest precedence. Operators in the same box have the same precedence. Operations with the same priority are evaluated from left to right. You can change the default priority using parentheses. I'll show you how I checked all the test cases with a script. That's all. Thanks for your attention. See you again. Bye everyone.